Okay, here's some chat about the area of triangles, and we're starting with a rectangle, and you'll see why in a second. We want to understand how to find the area of a triangle. We know how to find the area of a rectangle. Let's say this has an area or dimensions of 8 centimeters by 4 centimeters. Then we know that the area of this rectangle can be found by multiplying the length by the breadth, which is 8 times 4, which is 32 centimeters squared. So far, so good. Now, let's take a line and let's split this rectangle in two. And if we split this rectangle in two by drawing in one of its diagonals, then we can see that we've created two identical, or congruent is the maths word for identical, triangles. They are two right-angled triangles, and each of them is equal in dimensions to the other. We say they're congruent triangles. They're the same lengths and the same angles. So each of those triangles will have an area of half the area of the rectangle, because we split the rectangle in half. So the area of each triangle will be 16 centimeters squared. In other words, if we were to get rid of that one there, we could say that the area of this right angled triangle that remains would be half of whatever the length times the breadth is. In this case, 8 times 4, because as we just found out, half of 8 times 4 will give us the area. Half of 8 times 4 is half of 32, and that's going to be 16 centimeters squared. So from starting with our rectangle and cutting it in half, we can see that the area of a triangle is going to be half of what I call there the length and the breadth. Now that works just fine there with that right angle triangle, because the length is 8 centimeters and what we're used to calling the breadth is 4 centimeters. Doesn't work so well here though. Here's another triangle, and here we have a triangle, and we'll give it some sides. We'll say that's 6 centimeters, we'll say that's 8 centimeters, and we'll say that's 7 centimeters. Okay, in this situation here, it's not a right angle triangle, and it's not possible therefore to say what the height is. I'm actually going to draw another one if that's okay with you. That one maybe wasn't the most helpful one to start with. Here's a different one. We'll say this is 6 centimeters. We'll say 6 centimeters at the base. How about 7 centimeters there? It looks isosceles, doesn't it? Let's say it's an isosceles triangle. There we go. 6 centimeters, 7 centimeters, and 7 centimeters. Well, if we treat the 6 centimeter side as the length or the base, we haven't actually got the height given to us here, have we? Because these two sides here, the two 7 centimeter sides, are diagonals to the base of the triangle. And no matter which way you turn the triangle, no two of these sides give you the length and breadth of our triangle. So what we need here, and this is what you'd find it was given to you, what we need here is we need some indication of the height of the triangle. And so I'm going to draw in there, by hand, a perpendicular line. And I'm going to say that that is 5 centimeters in height. And what I've given us there is I've given us the height of the triangle. It's given to us naturally on a right angle triangle, but not on this triangle here, this isosceles triangle, because there's no right angles. And to find the area of the triangle, we need to find half of, instead of the length times the breadth, what we say is the base times the perpendicular height. The perpendicular height. These two 7 centimeter lines are not perpendicular to the base. Perpendicular means meeting at right angles. So the perpendicular height of our triangle is the distance from the bottom of our rectangle, which I've drawn as our 6 centimeter line, to the top, this point here. And you measure the height of anything, don't you, with a perpendicular line. You measure it at right angles from top to bottom. And that dotted line in the middle is intended to be that height. So to find the area of a triangle, you need a base and you need a perpendicular height. So in this case, our two dimensions are 6 and 5, so we multiply 6 by 5, which is 30, half of 30 is 15. So the area of this particular triangle would be 15 centimetres squared. Let's do another one. I'll do that one now that we had earlier. The reason I hesitated was because here, to draw the height from our base here, keep doing it. In order to draw the perpendicular height of this base, I'm going to have to go outside the triangle. I could go one of two routes here actually. I could start inside the triangle, go up to there, and then across to there, pretending that those are right angles. Or I could start here, I suppose, and I could come down here, and across to there again, pretending that I've created a right angle there. Now either of those will do, they're both the same measurement, and let's say it's 8 centimetres. Okay, so the area of this rectangle is going to be equal to half of the base times the perpendicular height, which is half, in this case, of 7 times 8. 7 8 are 56, aren't they? So that's going to be 28 centimetres. Here we are, so centimetres squared, remember the area, and there's the area of that triangle. So in practice, in exam terms, what are some of the things they give you? Well, they could do what they did in the first. Hey, guess what? I've done it again. They could give you all the sides, like so. Let's make it a 6, 7, 8 area, shall we? There we go. And they might give you all the sides as well as the perpendicular height, like so. I don't know why that's nice. You can't possibly do it there. Never mind. They could give you all of those dimensions in the attempt to throw you off the scent. Of course, here you'd be wanting this one and this one. Here's another triangle they might give you. They might give you again. Yeah. One day. Talk about a slow learner. We've got that, and that, and of course the perpendicular height can be given any one of a number of ways. They could give it to you like that, like so. So if this is the height here, this 4 centimetre line is the height. Which of those sides is the base? Well, of course, it's the side of the triangle that meets that height at right angles. So, in fact, the base here you would treat as being this line here, our 8 centimetre line. So, in this case here, it would be half. If we're going, and notice I'm always starting with my formula. It's very, very, very good habit to get into is to always start an answer like this with a formula. In this case, our two dimensions, our base here would be 8 centimetres, and our height of 4. And so again, you'd be looking at half of 32. Which is 60 centimetres squared. Don't forget to get your units of measurement as well. Okay, so just be aware that the height, the base is not necessarily the bottommost of the lines of your triangle. That's the area of a triangle. That's the formula. Area equals half of base times the perpendicular height. That's the formula. Apply it with the right measurements and you can't really go wrong.